In this tutorial I will show how to create fully dynamic tank tracks using the Ragdoll plugin. First we need to create a spline object. We will use it as a guide for our tank's tracks. With the spline object selected and the Shift key pressed, let's create a Ragdoll plugin in our scene. In real life, tank tracks consist of many pieces connected to each other in the right way. To create something like this in C4D, we need to create a single tank track piece, multiply it and connect all these pieces with dynamic connectors. This can be done manually, but I will use the Ragdoll plugin. The Ragdoll plugin allows you to do it much faster. Now let's adjust the particle size, remove up vectors that are not required in this case, and change the connector settings to a hinge mode that is easier for simulation. For the connector we could use the Ragdoll mode too, which is good for ropes. Now just rotate the hinge connectors to place them correctly. Set correct angular limits. Now we have a fully correct tank track. We can always recreate the chain, delete it and create it again with new amount of pieces, etc. Just don't forget to copy to a clipboard all the setting which we just changed. You can paste it back when the Ragdoll plugin will generate new set of connectors. Now let's create the rest of the tank's suspension structure. The main thing we would like to avoid during the simulation of the tank is tracks falling off rollers. The caterpillar particles must have a groove, the drive gear must penetrate into the groove with its spike. Then the drive gear will pull the track. The number of spikes on the drive gear must match the number of holes between the track particles. The gear spike should not protrude above the track surface. The caterpillar particles must be correctly connected to each other. Two adjacent particles must only bend in the same plane. The gears and internal rollers will move up and down over potholes, but the rollers should only rotate in one plane along the track. Many different parts connected to each other require a lot of computations, steps per frame. This parameter especially affects the stretching of tracks. If the number of steps per frame is low, the track can stretch and jump off the gears. The shape of the grooves, their location on the track particle, the number of particles, as well as the shape and position of the drive gear, the number of its teeth, can vary. The main thing is that the overall structure complies with the rules described above. Now let's properly connect the drive roller, suspension and axle. Select the axis joint and the suspension joint. In the Ragdoll plugin, select the mode of slider and hit Connect to. The Ragdoll plugin has automatically connected these objects with the slider connector. The slider connector is placed between two joint objects. The slider connector will restrict the movement of the suspension joint relative to the axis joint only along the connector's Z-axis. The Ragdoll plugin has also automatically restricted the distance of this movement by the distance between two joints. As we can see, the drive gear is not currently attached to the suspension. Let's connect them too. Now choose the wheel joint and the suspension joint. This time we will connect them by the connector in the hinge mode. In the Ragdoll plugin, change the name of mode to a finger/knee and click Connect to. The Ragdoll plugin automatically created a correctly positioned connector in a desired hinge mode. All that remains is to disable the angular limit checkbox. We do not need any limits here. Now the gear is attached to the suspension, and the suspension is attached to the axis. The suspension has no springiness. Let's fix this. Select the suspension joint and axis join. In the Ragdoll plugin, select the mode Spring and hit Connect to. Now a new spring object has appeared next to the other connector objects under the Ragdoll plugin instance. Increase the spring's stiffness. Perfect. All that remains is to create a motor that will rotate the gear and set our tank in motion. Ensure the correct colliding shape of all objects. Let's turn on the visualization of colliding shapes. In this case, the drive gear has automatic convex collision shape. Change it. In the rigid body tag, change the collision shape to a moving mesh. Play simulation. Perfect. Now our gear penetrates the grooves of the track with its teeth in the required manner. The drive gear now pulls the track. The suspension of our tank is created. Connect multiple axes with a connector in fixed mode to turn them into a rigid structure. Steps per frame parameter is very important during the simulation. Raise it to get more stable behavior. Now let's create the left side of our tank. We can just duplicate the right track and place it to the left. Also, I will duplicate the suspension. Just need to rotate some parts to place it correctly. I will cheat and just fix 2 axes cylinders by a fixed connector. But of course we can always leave them separated from each other. To make your tank like this one, just add the back wheels, regular rollers between them. And of course don't forget to add the main tank body and fix all parts to each other. Play with the suspension spring stiffness, mass of different parts of tank and the motor speed to achieve the desired result.